Welcome to lesson 58 of course 2. This lesson is on symmetry. We're going to identify and draw lines of symmetry in figures, and we're going to identify and draw figures with rotational symmetry. For vocabulary, we have the term or the phrase line of symmetry, a line that divides a figure into two halves that are mirror images of each other. That means symmetry. So as you can see, each of these has symmetry because each one has an exact half, so that if you were to fold them in half, they would line up, where none of these do. Those do not have lines of symmetry. Now, reflective symmetry is the same thing. You divide something into mirror images along a line known as a line of symmetry. So an isosceles triangle has reflective symmetry because we know that we could fold this in half and we would have line of symmetry. We'd have two mirror images. So a two-dimensional figure has reflective symmetry or line symmetry if it can be divided in half so that the halves are mirror images of each other. If we were to take a look at this regular triangle, meaning that it has all equal sides, you would see that it has three lines of symmetry. Here's our first one. As you can see, you have the two sides that are identical to each other, and then here again we still have two sides identical to each other, and here again we still have two sides that are identical to each other. So we have 1, 2, 3 lines of symmetry in a regular triangle. So draw for me a regular quadrilateral and show all lines of symmetry. You're going to start by trying to draw as good as you can a regular quadrilateral. So I'm going to draw a square, and then I'm going to start drawing my lines of symmetry. There's 1, there's 2, there's 3, there's 4. Do you see any others? Those are all the lines of symmetry. Each one of those creates a mirror image. Okay, let's look at a little bit different of a mirror image. This one here, the y-axis is a line of symmetry. Right here is a line of symmetry. Notice that on each side we have corresponding points that are in the same spot, such that if we were to fold it over in half, this 2.2 would land right on top of that dot, and this 3.0 would land right on top of that dot if we folded it in half. That's symmetry. So think of some objects that you have there in your room or your house or around our classroom that have lines of symmetry. They have one or more than one. And what are some objects that you can see that don't have symmetry? Take out a piece of paper and fold it in half. Grab a piece of scissors. Just do this little experiment for me if you would. Just grab a piece of paper and scissors, fold it in half, give it an edge, then begin and end on a folded edge, cut a pattern out, and then open it up and note the symmetry. Notice how it's the same. It's a mirror image on both sides. You're going to have one line of symmetry. Now, fold a piece of paper twice. Fold it this way, and then fold it again down this way here, and then cut a corner out, and then unfold that, and then see how many lines of symmetry you see this time. So let's see how we do. A figure with rotational symmetry means that the way it looks in its original position, like this right here, the way it looks when you rotate it around, when you turn it, when you flip it on its side, then on its side, then on its side, and you rotate it around, it shows up again. It's like the letter S right here. If we take S and we turn it upside down, it still looks like an S. But if we lay it on its side, it no longer looks like an S. Or the I. If we turn it upside down, if we lay it on its side, it looks like an underscore, but when we stand it back up, it looks like an I again. So the letter S and the letter I both have rotational symmetry. So look at these shapes and tell me which one of these will not, as we rotate it around, will not look like itself as we rotate it. You should have said D, because as we rotate this rectangle, that doesn't look like it, but the next rotation it's going to look like it again. So A does. B does, obviously, because every time we flip it over, it still looks like a triangle. Same thing with C. No matter how many times we turn it, it'll look exactly like it does. But D will never look like this again until we get it all the way around. There's your written practice. Thanks for watching the video, and we will see you tomorrow.